All right, people, I know you've been sitting wondering, Sarah, you gave me the law of sines, and we know, oops, as I bang my knee on my office desk, we know that the law of sines, right, which we've come to know and love, have enjoyed, the law of sines allows us to solve triangles of the type angle, angle, side, right? Angle, side, angle. And then this one, you have to be very careful what order you put this one in, but also side, side angle, right? And now I'm sure you've been wondering, you've been lying awake at night, concerned over, but what about the other ones? So fret no more. You'll sleep well tonight. You might sleep really well while you're watching this video. But the law of cosines is what we're going to use to solve those two last triangles that you've been worried about. And those two last triangles are side, angle, side, and side, side, side. So these triangles, the problem, not a problem, but the issue, I suppose, with triangles of these type is that we can't actually use law of sines. So side, angle, side would be, I'd have a side, I'd have two sides, and maybe, the included angle, let's say. So the problem is with the law of sines, remember, you need to have an angle on its opposite side. There's no way for us to find the opposite side of 95 degrees as is. There's no way for us to find an opposite angle of, from 4 or 7, just given the law of sines. So we need a new law, and this new law is called the law of cosines. So I also want to prove this for you because I don't want you lying awake tonight wondering if what I actually told you is true, wondering where this law of sines came from. I'm sure that's what's going to happen if I don't prove this for you. Actually, I really want to prove this for you because it's a pretty simple, I don't know if simple is the right word, but it is a proof that you can follow. So I'm going to take a triangle, and I'm going to remember the idea of the law of sines and cosines is to be able to solve a triangle that's not a right triangle. So I'm just going to put this triangle, so make something that's not a right triangle, that's not 135 degrees. I'm just randomly, ooh, that was pretty good. That's nice. If you don't say so myself, that's a pretty nice purple triangle right there. I'm going to put it on the XY coordinate system because I want to use, cosine and stuff. And so, well, you'll see. Okay, so here's my triangle. I'm going to call this angle, angle A. Okay, I'm going to call that, I'm going to put one of the angles right on the origin right there. I'm going to call that angle C, and then it's going to come out to be here. So what do I know? I know a couple of things, right? I know that the opposite side of A is side A. The opposite side of B is obviously little b, and then we'll call the opposite side of C little c. So there are a couple things I know. If this distance right here, you guys, is A, then what do I know? This point right here must be the point A0, right? I know that this is 0, 0. Okay, and then I'm going to call this point right here that represents where the angle A kind of starts, its vertex. I'm going to call that, I don't know, let's get crazy and call it XY. Right? All right, and so just like when we had the law of sines, and remember how we drew the altitude of the triangle and we kind of forced a right triangle? That's exactly what we're going to do here. I'm going to kind of force myself to have a right triangle, and the way I'm going to do that right triangle is I'm just going to come down here, and this is all without loss of generality, right? I'm putting C here at the origin. I could have put A, I could have put B. I'm going to prove there are 3 parts to the law of cosines, just like there are kind of 3 parts to the law of sines as well. And I am going to just show one of those, and then I'll let you, enjoy figuring out the other ones. So if I draw this right triangle right here, I just want to point out a couple of things. So this length right here is B. This length must be y and it's positive. And then this length here, right, because I called this point xy, this length right here is just going to be x. And realize that x is negative because we're in the second quadrant. Okay, all right, so here we go. So given the setup that I have there are a couple things that I can see. Let's think about this angle C right here. How would I find the cosine of that angle C? Well, remember the cosine of any angle, now that I'm not restricted to having an angle that's just acute. Remember, cosine we've defined, right? Cosine of any angle we define to be x over r. So it's the x coordinate of the point. I know I go through, right, and r is the hypotenuse. So in this case, right, the same idea, if I do the cosine, I'm going to do x over r, but in this case, what is r? It's just going to be b. So the cosine of c is going to be x over b. And notice this makes sense. X is in the second quadrant, so x is negative, right? And we know cosine is negative in the second quadrant. So I have that the cosine of c is equal to x over b, and then I'm going to do kind of the same trick I did with law of sines. I'm going to multiply both sides by b, and I get that x is equal to b cosine of c. Likewise, if I do the same thing with sine of c, remember sine is y over r, but in this case my r is that length b. And so we see that y is equal to b sine of c. Okay, so my point, right, then if I look at the point xy, I could, if I wanted to get a little crazy here, I could rewrite this point xy as what? B cosine of c, comma, b sine of c. All right, you following me? You picking up what I'm putting down? I hope so. Sometimes I try and say things that are cool, and they're probably not. My daughter, who's 8 right now, is getting quite embarrassed of me already, which is very sad, but poor thing. Okay, anyway, so I know I can rewrite that coordinate like this. So what I'm going to do now is I'm basically going to figure out, well, you know, if I were given maybe these two sides and the angle C, is there any way that I could find this length, little c? So my goal now is to find the length of this side right here. So I want to find the distance of this part of the triangle right there. Well, you guys, do you remember the distance formula from 1400? Well, or from college algebra? Of course you do. I taught it to you, of course. The distance formula, right? So I'm going to, let's erase some of this so I have some room. I'm going to use the distance formula then to find that little c right there. Use the distance formula. Nope, I need to put a pen. There we go. So let's use the distance formula. Remember, the distance formula is basically just the Pythagorean identity. That's all, Pythagorean formula. To find little c. Okay, so the distance, right, little c then is going to equal, so remember what the distance formula is. It's the square root of, and in between any 2 points, x2 minus x1 quantity squared plus y2 minus y1 quantity squared, and the square root of that. That's our distance formula in the Cartesian coordinate system. Okay, so c then is going to equal, well, let's just take my x here and subtract my x here. So it's going to be b cosine of c minus a, right, quantity squared. So I'm just taking the difference of my x values. Then I add the difference of my y values. So that's b sine of c minus 0. Well, we know what that is, quantity squared. Now I don't like the square root, so I'm just going to square both sides to get rid of the square root. And notice what I have here. So I'm going to go ahead and FOIL out this guy. This guy is b cosine c minus a times b cosine c minus a. Don't you dare square each term. Don't you dare. Can't. So I'm going to FOIL this out. It's going to be a good time. I'm going to get b squared cosine squared of c. On my outside, I'm going to get minus ab cosine c. On the inside, I get minus ab cosine c. So I'm going to get 2ab cosine of c. And then negative a times negative a is positive a squared, obviously. And then here, that 0 is gone. So I just get plus b squared sine squared of c. Oh, you guys, this is so cool. Okay. C squared then equals, and if you, okay, so you're not going to think it's cool because you probably don't really know what the law of cosines is right now, but for those of you who have seen the law of cosines, it's fun to see it proven. So, all right, so notice I have, I'm going to put that a squared term first. Here, if you notice, I have two terms with b squared in it, so I'm going to factor that out. And I have sine squared c plus cosine squared c. Yes, I know, it's exciting. Wait for it. And then look at what I have right here. I have minus 2ab. This is so great. Cosine of c. And now, people, it's true. It's what you thought it was. It's so exciting. What is sine squared plus cosine squared? My friends, that is equal to 1. So what is the law of, let's make some more room up here. One part of the law then of cosines is all of this right here that I was trying to erase. It's c squared, or the length of the side opposite c, is equal to a squared plus b squared minus 2ab cosine of c. And we're going to write this all down nice and pretty. But that is one of the steps of the law of cosines. And it's a pretty easy one to see. Well, easy is relative. But I hope you can kind of see where that came from, right? I'm going to give you the law of cosines. Law of cosines is can be kind of tricky to memorize, right? So I'm going to go ahead and give this to you. Don't fret, but you need to know how to use it. So let's write this down. Now, I can do the same thing with all of these. I could go through and find the distance formula for A and find the distance formula for, use the distance formula to find B. So that's, I just want you to be aware of that. And so that's how we get 3 different kind of parts to the law of cosines. So let's write this down. The nice thing is with the law of cosines, we are not going to have, so this lecture will not be an hour, I promise. We're not going to have those ambiguous cases like we did with the law of sines, or the no solution. Everything is going to work out fine with the law of cosines, okay? Law of sines, not always so much, but here is the law of cosines, okay? So for in any triangle, we'll call that triangle, again, let's get, I see it. In any triangle, ABC, get a little crazy here, right? Here's what we have for the law of cosines. A squared is equal to b squared plus c squared minus 2bc cosine of a. So here's a couple patterns that happens with the law of cosines. So if I have a squared equals, what you do is you take the square of the other sides of b and c, add them together, minus twice those two multiplied, and then it's always going to be cosine of the angle that's opposite that side that you're looking at. So like b squared in this case would be a squared plus c squared minus 2ac, and then it'll be the cosine of b. And then finally c squared is equal to, which we just proved. We proved that one, right? A squared plus b squared minus 2ab times the cosine of c. So great. Okay, that is the law of cosines. And now and of course, I could solve, so based on what you're trying to find, if you're trying to find a side, right, you'll just leave it like this. If you're trying to find cosine, I still start with this. In your book, they like solve for each one. But what I do is I still start with this whole thing, and then I just go and I solve for what I want. Don't worry, I'm gonna show you how to do that. So let's look at an example of a side angle side. And we'll just kind of keep that hanging out. These are really, really fun to do. Now, I knew that was gonna happen. Guys, these are so much fun. I am not joking. I really enjoy doing these. I know, I think there's something wrong with me, but that's all right. I'm all right with it. So let's solve the triangle ABC, right? That means find the measure of all sides and all angles given. Here's what we're going to do. Let's do a side angle side. So what do I know? I know that, let's say, A is 115 degrees, B is 15, and C is 10. You could do 15 centimeters, 15 meters, 15 millimeters, whatever you would like to do. So I'm going to draw a quick picture of this. So 115 degrees, I'm going to just draw something like this. Now the way that I've drawn that, I know in my example, right, or when we proved this, this was C, but it doesn't matter in this case. If this is A, that's fine. That's 115 degrees. Let's let this be B, and let's let this be C. So where do I know little b is? This then would be 15. Little c would be 10. Now the only thing, so if you look at what I'm given. I'm given capital A, little b, and little c. So if I go back to my law of cosines, right, what am I going to be able to solve for? Well, remember what I know. I know capital A, I know little b, and I know little c. So in this case, I don't know little a, so it's not going to help me at all to use this one or this one. What are we going to have to solve for? We're going to have to solve for little a. That's really all I have available to me to do. If you look at this, how do you know you can't use law of sines? So that's something you're going to have to figure out, right? Am I going to have to use law of sines? Am I going to have to use law of cosines? I can't use law of sines because in order to use law of sines, I need an angle on its opposite side, and I don't have that. So we're going to use the fact that a squared equals b squared plus c squared minus 2bc cosine of a. Okay, and we're going to go ahead and plug this in. So what does a squared equal then? That's going to equal 10 squared plus 15 squared minus 2 times 10 times 15 times the cosine of 115 degrees. So I'm going to grab my calculator. I'm going to put my mode into degrees, which it was not. Please make sure you're in degrees. And let's figure this out. 10 squared plus 15 squared minus 2 times 10 times 15 times the cosine of 115. I can put that all into my calculator as is. Ooh, so I get a squared is equal to this big number, like 451.785, blah, blah, blah. All right, so, whoa. We have 785, 4785, blah, blah, blah. So how do I find a? So that implies square root both sides. Normally I yell at you to take, I don't yell, I encourage you to take a plus or minus anytime we bring in a square root that was not there already. However, in this case, this is the side of a triangle, so I know that this is positive. So what is A? A is 21.26 centimeters, meters, whatever we are dealing with. All right, so now because we have A, so we have A now, and remember, mathematicians are inherently lazy, so we want to make sure that we do this in the easiest way possible. So now that I know little a, I am able to use the law of sines, right? Now that I have that little a, I can actually find, and I know that this triangle exists also. The other nice thing is I know that this triangle is going to be, I have 115 degrees. I know that I cannot have two triangles, right, with obtuse angles. And law of sines, remember, when we look at that ambiguous case, we have to consider an angle being in the second quadrant. I already have an angle in the second quadrant, so there's not going to be that ambiguous case when I use law of sines in this case. So let's go ahead and use law of sines from now on. Now listen, you could use law of cosines, that would be fine from here on out, but I think the law of sines will be a little bit easier now. So if I use law of sines, doesn't matter what angle we want to find, but let's go ahead and find angle B. So I'm going to take the sine of B all over, the opposite of B is 15, is going to equal the sine of A, which is of A, not little a, of 115, right, all over 21.26. Okay, so how do I solve for B? Well, that tells me that the sine of B, I'm going to multiply both sides by 15, is 15 times the sine of 115 all over 21.26, and now I'm going to take the inverse sine. So if I take the inverse sine of that, inverse sine, again, making sure I'm in radians, divided by 21.26, right? Look at what we get for B. I get 39.75 degrees. Again, why am I sure, right, that the law of sines is going to work for me? Because I already have an obtuse angle. Law of sines, when you look at that ambiguous case, you always consider 180 minus this. Is that a possibility? No, because B can't be obtuse. We already have this obtuse angle. And so we are good to go. We know that there can't be two solutions. All right, so let's see what we have so far. I like to kind of write this out and make sure that I have everything I need. I know that angle A is 115 degrees. I know that angle B, I just found that out. That was 39.75 degrees. Can I find angle C? I sure can. I'm going to take 180 minus 115 minus 39.75, right? Because all the angles of a triangle add up to be 180. So angle C is 25.25. That's cool. And now I just need my sides. Little a, or side A, is 21.26. B was given, that was 15. And C is 10. And we're done. I didn't even, well, I used side C for the law of cosines. Isn't that great though? I just love the law of cosines. I think it's real simple. There's not that ambiguous case. You know, it's a good one to use. Let's do another example with the law of cosines where we have side, side, side. Okay, so another example with the law of cosines where I have side, side, side. So three sides of a triangle. Let's solve the triangle ABC, where all right, little a right, let's say is 8, side B is 19, and side C is 14. So I don't know any of the angles, but I know all the sides. So I'm going to sketch this triangle. I always just sketch it the same way. You don't have to. But I know the way I've sketched this, then this must be B, right? Because that's the side that has is opposite. That is the angle that's the largest, so the side opposite must be 19. Now, I don't know that B is obtuse, right? I'm just drawing a triangle, so it could be acute. I don't know, but that's okay. I'm going to say that this is C. So that must be angle C over there, and then we'll say that this is A. Now when you're doing something like this with the law of cosines and you're given all sides, what you always want to do is you want to start off with solving for the largest angle. And the largest angle in a triangle is always going to be opposite the longest side. The reason we want to do that is because then if we get an obtuse angle, we'll be able to use the law of sines without having to wonder, right, if I have this ambiguous case. Sorry, the word ambiguous sometimes is hard. So I want to solve for B. I want to solve for angle B first. Okay, so what I have to use then, if I want to solve for angle B, which of these involves angle B? Well, this one right here, right? So I'm going to go ahead and choose this one because this is the only equation that involves angle B. And then I just need to solve for angle B. Okay, so what do we know? I'm going to use that equation. B squared equals A squared plus B squared. Nope. A squared plus C squared minus 2AC times the cosine of B. So let's plug in what we know. So I know I have 19 squared equals, right, 8 squared plus 14 squared minus 2 times 8 times 14 times the cosine of B. And let's start simplifying some stuff here. So 19 squared, I didn't know that one off the top of my head, is 361. 8 squared plus 14 squared is 260. And then I can even simplify this. 2 times 8 times 14, right, is 224. Now right here, I need you to be very careful. This is a mistake I always see when I teach this. I see students take that 260 and subtract the 224. Don't do it. You can't. Why can't I? Aunt Sally would be so mad at you. Please excuse my dear Aunt Sally. These two need to be multiplied together first before you can do any subtraction. So you can't do it. You cannot take 260 minus 224. So how am I going to get cosine of B by itself? And first I'm going to subtract the 260 from both sides, right? I feel like I should be able to do that at 101, right? I just sometimes don't trust my arithmetic. I'm going to subtract the 260 from both sides, and don't forget this negative stays. This negative is hanging out with 224, right? And now finally, let's give ourselves some room up here. Whoosh, we'll go up here. Okay, what am I left with? I'm going to divide both sides by negative 224. So I get 101 divided by a negative 224. Okay, so how do I find B then? B equals cosine inverse, and right away I know B is obtuse. How do I know that? Pretending like you're answering me. How do I know that? I know that B is obtuse because I'm taking the cosine inverse of a negative number. And remember, cosine inverse spits out angles in the first and second quadrant. So because that's negative, I must be in the second quadrant. So I'm going to take cosine inverse of 101 divided by a negative 224. Okay, making sure that I'm in radians. And, or no, in degrees. This is I don't know why that's bad, but 116.80098. So let's just put 116.8 degrees. Okay, so look at what I have now. I know then, let's give ourselves a little bit of room here because we still have a couple other things to solve for, right? Well, we have two other angles to solve for. I know that this is, I know that this is 116.8 degrees. So I might as well go and solve for the next biggest angle. Okay, well, I guess it doesn't, you could solve for the smallest angle too. I have an obtuse angle, right? I have that 116.8 degrees. So I'm not gonna need to worry about having an ambiguous case because I solved for that biggest angle, and I know there's no triangle can have more than one obtuse angle. It's not a triangle anymore. So let's go ahead. It doesn't matter which one I want to solve for now. We can go ahead and solve for A. I kind of like to go in order. So let's solve for A. Ooh. Using law of sines. It's just easier, right? I like them both. You know, it's like your children. You can't have a favorite, right? I'm totally going to wait to see which one of my kids is better at math before I have a favorite. Kidding. It was a joke. Joke. So I want to solve for A. So what do I know? I know the sine of A, right? All over 8. Now that I know B, I know that this is the same as the sine of B, which is 116.8 degrees divided by 19. And just like we've seen before, that tells me then that the sine of A, I'm going to multiply both sides by 8, is 8 times the sine of 116.8 degrees. You know the drill, all divided by 19. Let's take sine inverse of this guy. Again, I know that this is going to be, sorry, I can't do those. This is going to be the only solution. A is equal to 22.08 degrees. Remember, if it's the ambiguous case, if we need to check to see if there's another triangle that satisfies these conditions, right, I would take 180 minus 22. But again, that'll give me a solution that is obtuse, and we already have one obtuse angle. That's why it's always, always good to solve for the biggest angle first if you don't know where any of the angles are. Because if you get an obtuse angle, then you're ready to go, and you can just go ahead and not have to worry about that ambiguous case that you would have using the law of sines. B, we found 116.8 degrees, right? C, I'm just going to take 180 minus 22.08 minus 116.8. So angle C then is 41.12 degrees. And then we know the sides already, they were already given, but I'm just going to kind of write them down again, because remember, my biggest side should be across from my largest angle. That would imply then that my smallest side should be across from my smallest angle, and that's all making sense. That's one way that you can kind of check yourself. You know, if you see anything in there that doesn't really work out, watch for that and see, you know, make sure, right, that is going to, that it follows kind of what we expect it should when we're dealing with a triangle. All right, you guys, I think I might stop. I know this is wild. Only at 27 minutes. Law of cosines is pretty great. There's some application problems with law of cosines that you'll see, but it's really no different than how we're solving this. You know, I know you guys can figure those out, so you can do those application problems. They're nothing different than any of the application problems we did when we had right triangles. We just don't have right triangles anymore. Let me know if you have any questions. I hope you enjoyed this. Go out and have some fun with the law of cosines.